welcome to my channel again. So today we'll discuss the differential equation. So it is an important topic in the syllabus, that first order differential equation. Now consider two variable linear equation. Suppose y is the function of x, so y is the dependent variable, x is the independent variable, and form is x squared. So y is equal to x squared. And x, the value of x ranges between 0 and 3. So y is dependent variable, x is independent variable. So the functional form is y is equal to x squared. Now if we take first derivative of this, dy by dx is equal to 2x. We have already got in the derivative in the differentiation chapter that dy by dx here will be 2x. The power multiplied by power, then variable to the power minus 1. So this is 2 minus 2x. So dy, so if we transfer 2x towards left side, so dy by dx minus 2x is equal to 0. Now this equation, dy by dx minus 2x is equal to 0, is called a differential equation. Now why it is differential equation? That it is expressed in terms of the differentiation. Now if we simply write y is equal to say x squared, this equation y is equal to x squared, and it is similarly algebraic equation, but when we will express in terms of the derivative dy by dx minus 2x, this becomes a differential equation. Now what is order of differential equation? So this can be expressed geometrically as this curve, because when x is equal to 1, y will be 1. When x is equal to 2, y will be double. Like that. Now, order of differential. This is the highest order of the derivative or differential. Now, what is the highest order of the derivative in the appearing in the different equations? For example, first order derivative dy by dx is the first order, because the highest power is 1. Then d square y by dx square is the second order, and so on. So first order linear differential equation with constant coefficient and constant term. Now what is this? Then degree of differential is the highest power attained by derivative in the equation. So here we have discussed the order of differentiation. Here it is the power of differentiation. The degree of differentials. It was order of differential. Now it is degree of differential. So this is nothing but the highest power attained by derivative in the equation. For example, dy by dx. So highest power is 1. Now dy by dx square. So highest power is 2. So on. Dy by dx whole power is 3. So the power here is 3. If the dependent variable is of first degree, if the dependent variable is of first degree, like this. If the dependent variable is of first degree, the differential equation is linear. So when the differential equation is linear, when the dependent variable is of first degree. So y is equal to a plus bx. Y and x are linearly combined as their highest power. is 1. So general form, now the general form of linear differential equation of power n, how it is written. Suppose the power is n. So h naught x d to the power n y dx to the power n, okay, plus h1 x d to the power n minus 1 y dx n minus 1, plus and so on. Like h n minus 1 x dy by dx plus h n x y is equal to the f(x). This is the function of x. So this is the expression of general form of linear differential equation. So when we call it a linear differential equation with constant coefficients, okay. So if the coefficients of y, if the coefficients of the dependent variable and its derivatives, that means h naught x with respect to x, derivative with respect to x, then next derivative with respect to x, and so on, are all constants. See, if all derivatives are constants, it is called a linear differential equation with constant coefficients. Let a naught, a1, so on, an are constants. Then a naught dn by y, dn y by dx to the power n plus a1 d to the power n minus 1 into y by dx to the power n minus 1 plus so on up to an minus 1 dy by dx plus next will be an y is equal to fx. So if fx is equal to 0, suppose this is equal to 0, then we will get a homogeneous linear equation with constant coefficients. So fx must be 0. Now total differentiation. If y is the function of x, dy by dx is equal to f prime x. F prime x means this is the first derivative with respect to x. So sometimes we write fx x, fx x, that means first derivative of x. Then sometimes in some book you will find it is f1 x, that means first derivative with respect to x. And in some book it is f prime, that means first derivative with respect to x. And f prime prime means second derivative with respect to x. So dy by dx is equal to f prime x. Now considering change in the independent variable, suppose independent variable has changed, then dy can be defined as, so dy, suppose there is change in independent variable, dy is equal to f prime x dx. So this is the differential of fx. Now dy by dx is equal to, we have got it, dy by dx is equal to f prime x. That means dy, practically dy is nothing but the cross multiplication. Dy is nothing but f prime x into dx. So this is defined as dy. Okay? That means change in y. Change in y due to change in x. This is the differential of x. It is called the differential of x. for n variables, suppose there are n number of independent variables, y is the function of x1, x2, x3, so on up to xn, then dy, change in y will be f1 dx1 plus f2 dx2 plus so on fn dxn. So this is widely used in economics interpretations. So we should remember that if y is the function of n number of independent variables, then change in y, when all variables will change at the time, then change in y will be first derivative with respect to the first variable plus first derivative with respect to the second variable, and so on. Okay. Thank you very much. We will continue. It is a long chapter and important in understanding economics. We'll go on illustrations, solutions. Thank you very much for watching. Keep on watching and please share.